How are we all doing? I hope you're keeping well out there. So, regular contributor to the channel, Joseph Malloy, presented me with this the other night. It's an Advance P1 RF signal generator from the late 50s, maybe early 60s. As we can see, it hasn't been used for quite a while. Still has this hanging on the end of it. They've kind of gone out of fashion a while ago. So I just thought we'd take a little break from the GC at the minute and we'd have a look at him, see does he come on, have a look inside. And what I'm going to do is I'm going to open it up and we're going to have a look inside, and then we're going to run it up on the Verdiac if all looks well, and we'll see what the story is with it. Right, screws out, let's take him out of the case. Advanced stuff is always very well made, to be fair. I've had quite a bit of it through here over the years, and they make very good, general workshop grade signal generators, but very good quality. They're not lab grade, they're not Marconi or HP, but they're very good service generators. And this is no exception. Lovely, well sealed coil box. Way better than, say, for example, here's one I use regularly enough as well, but this is an old leader, LSG 100 or 200 should I say. Same idea, just a little bit newer, but has nowhere near the screening in it that the Advance there has. And also, unlike our friend the Advance, this has a calibrated output in microvolts and millivolts, but you have to use it with a dummy load or a dummy area. We'll get into that a bit later, but of course it uses the old the RF jack is a bit of a nuisance because it's a car aerial type. We have a few of those plugs in stock somewhere, and this is, again, you can see plenty of screening, good quality stuff, good RF chokes feeding into the coil box, so it's well sealed up. That is the HT rectifier, a little selenium rectifier. And there's the mains transformer, on off switch, and we can see that the drive for the dial is nice, simple, friction spring loaded drive directly onto the dial there, and the dial is illuminated by this nice bulb, so you know it's on and you can see it in the dark. Modulation transformer for the modulated output, modulated RF, and also you have AF out, so you can use it to test basic test on amplifiers. So yeah, nice bit of kit. Type P, Model 1. They made a few different ones. There was the E as well, but I don't think there's much difference between any of them. They're all pretty much the same, of the same ilk. So let's have a squint here. We've got a 6J5 GT, which has, and I noticed a lot of these are doing it, these Brymar ones, the little skirt is snapping on them under force, where I think the glue is expanding or something. I've seen quite a lot of them snapped open like that. It's not an issue though, just have to be careful if you're removing the valve. Suppose we could have a squint inside the coil box. There's going to be capacitors to be replaced in this, I'm sure. There we are. No. There's me right. Lovely bit of kit. We've got an ECC 91, which I think was a VHF valve, double triode. But yeah, quite nice. Couple of little caps there that could be replaced. These licoricey ones, which will no doubt be leaky, but we won't worry about too much yet. You see, nice bit of kit. Well made. Well made. don't make stuff like that anymore. We certainly don't. We will get the Verdiac out and run it up slowly just to see what she will or will not do. While the caps could be replaced, a lot of these are in workshops, still in use, never having been opened, which is amazing. So, items of concern would be that the selenium rectifier might be past its best, causing low HT and things like that, but we shall see. Yes, right, we'll set her up with the Verdiac. Okay, so we're ready for power up. A couple of things going on here. We have a frequency counter hooked up to the output. We have the Evo 8 Mark III here, which is going to measure the HT at the reservoir cap after the smoother. So we are going to wind her up on the Verdiac and we're going to see what happens. Incidentally, I've set the RF output to maximum and we're on range D. Counter sitting about 1.6. Let's put the marker down on 1.5. 1.5 megahertz, right? 1500 kilocycles, and we will see if that happens or not. This will probably work. Most of them do once you wake them up gently like this. So we're ready for action. So we'll start winding her up. $40, $50 volts. Nothing reading here. This should come up pretty quick because it's a selenium rectifier, so we're not waiting for like a valve rectifier heater to come on. The usual mistake I often make when I'm doing this, you have to switch the voice under test on. Let's try that again. So wind her up slowly. Let's go. 20 volts AC, 40 volts AC in. Oh, we've already got a glimmer on the dial lamp at 40 volts, and we have just under 10 volts HT. Now, having a quick cursory look online, I think we're looking for about between 130 and 160 volts HT for this to chooch correctly. We keep going. 60. 65, 15 volts HT coming out. I'd say that's selenium rectifier is probably gone a bit lazy. Dial bulb's getting brighter all the while. Can we see the 6J5 light up yet? Not yet. Keep going. 70 volts. 80 in. 20 out. Yeah, that's not great. I'd say that selenium rectifier is past its best. What we do with that is we replace it with a diode, like a 1N5401 or something like that, 5407. And probably a 10 ohm resistor, maybe a 22 ohm resistor, something like that. So well, you can mess around until you get the HT right, and we'll probably aim for about 140 or 50 HT if we're doing that with this. 20. I wonder will she work at all then with the low HT. 100 volt AC in. I can see the top of the 6J5 is just starting to light up there. We'll knock off the light real quick and you can see it. See a little dot of light just underneath that wire there, the aerial, the wire going into the RF counter. You can just see a little dot of light there. So it's lighting up too. Let's keep going. Whoa! Action. 30 voltage T, not even, near enough, and 116 input, and the counter is reading 1496, and we're actually, funny enough, if we look right down on this, look where we are, we're just under the mark. That looks around 1496. Let's center that right on 1500. That's not bad, is it? Huh? 130 volt to HT. And it's bang on. Let's see what happens when we wind her up a bit further then. Will she stay stable? 120, 130, 140 volt AC in. HT's low, alright. A lot of people have remarked that these advanced generators really do hold their calibration, and this is certainly doesn't seem to be anything other than true here. 170 AC in. Everything's looking good here. $200. 220 and about 55 volt HT, smoothed HT, so that's not right. However, it doesn't seem to mind it. Look at that. Isn't that something else? Just look at that dial light up the shed, huh? That is lovely. What's she like on the other bands? Let's go. One we use quite often, 455, which would be about there. Yeah. It's spot on. It's spot on everywhere. 450. Yeah. Bang on. What's she like on the higher bands? Now this is where she might, with the low HT, she might not be inclined. We'll go for, oh wait. Oh no, I should be able to read that. Goes up to, the counter goes up to 200 megahertz. When you flip that button. 38 point. The decimal point doesn't move over. Maybe it will if I do that. No. On 200. Anyway. 38 megahertz. Let's go 40. Bang on the line of 40. That's not bad. That's not bad at all. We zeroed the meter on that. 40 megahertz. Never made to be this accurate anyway, but 40 megahertz. Yeah, it's a little bit, but like a fraction. That is spot on. Let's go all the way up to the dizzying heights of 100 megahertz. That's the top end of what this thing can do. Will she keep oscillating up there with the low HT? It seems to be happy enough with that low HT. There's 100. 100 megahertz, and she is. Scanner lined up right there. For a workshop grade bit of kit, it's spot on. It's spot on. If we look at where the pointer is, there's the clock. I mean, we wouldn't fall out with that at all. Yeah, advanced rule today once again. However, things to be done. Probably would want to up the HT a bit. It is a bit low, 50 volts, when it should be 130. Between, I think it was 130 and 160 I read somewhere. So we'll probably bang a diode in. Changed a couple of caps in it for future proofing. We will measure the leakage in them. And yeah, we'll see where we go from there. The last mark on this is 102 megahertz, and yeah, kind of spot on. And she oscillates all the way up to the end of the clock, 106.4. I wonder, can we pick it up on the workshop stereo?
Not his reading. On air.
There it is. Turn on the modulation. She's a bit microphonic. Not incredible. Let's see if she'll pick it up on medium wave then. We'll go down to... Oh! The HT drops when we go for to the highest band. See that? Just a little bit. Look, yeah. Probably a few leaky caps to be dealt with, alright. But we'll see, can we... Let's put her around 1000 kilohertz. There. Wrong end of the clock. Good day. Look, it's spot on. It's absolutely spot on. No. Mess around with this for a second. Right, workshop stereo didn't want to comply, and I think the output on this might be a bit low. I've also discovered another issue. We've no AF modulation, and I have heard it said, someone else mentioned on their one, that the modulation transformer went open circuit, which wouldn't be good news.